whenever Narendranath comes to the US, we will call and go out for lunch or something. But this time, I was fortunate enough to grab him for a seminar. He is actually here for a 1-week conference on water next week in New Orleans. He has been a pioneer in introducing a number of technologies. His background, the educational background is agronomy, agricultural sciences. Right? But his passion is animal sciences. And his management skills are, of course, everywhere. But you will see today in sugar industry, how he has innovated the sugar industry in India. And he has anecdotally told me a number of occasions, and is also told by other people that know that in the sugar industry in Louisiana, there are incidentally 13 or so sugar mills and several refineries as well. So these plants are running for a very long, like 50-year-old plants, so they're still running on old technologies. But the rapidity with which he introduces innovation into this plant is the amazing story for me. I can't mention. When I first heard from Badin's experience when he visited him in India, in 3 days, Badin conceptually draws some drawings. Narendra gives it to his engineers. It's transformed into an actual unit within 24 hours, ready for testing. And that is the rapid cycle of innovation that I've been talking about within Epic. Why don't we have it in chemical industries is my question. And here's an example of how it can happen. And this is happening in India in many places. It's happening in China in many places. I don't know whether you have read a book. This is not an engineering book. Thomas Friedman, New York Times columnist, with the title, That Used to Be Us. Look up that book and read that, and you will see what lessons we can learn about the rapid innovations that are taking place around the globe, the impact of globalization. So with that, I would like to welcome Mr. Narendranath to the seminar today. Please join me.
Thank you for coming. Like I said, I am an agronomist. I am no process engineer or nothing, so I may not be able to give you much of the details. In case you have any doubts, you may slip with your email. I give you the answers. Except the last 10th point, every other thing we've done in plant at our sugar plant. I started with the diffusion because that's the starting point of the thing. We've been using diffusers for the last 40 years. And we've now come to a stage we've designed the third diffuser we put in the third plant, we designed and built ourselves. And now I think we're doing better than what the original diffuser was, which we got technology from Belgium. The second thing is the flotation clarification thing. And the second is the flotation clarification. This was an accident. My son printed it out for me and thinking it's a flotation clarification of cane juice, that it happened to be a white wine juice. So then we said, okay, why not try with this juice? It gave us a 20% reduction in color of juice, because the phenols were getting off stage. And then the third one is, of course, what Vadim did here in Nardwan Sugar Institute. And the fourth is the diffuser clear juice. This clarification of juice in the diffuser was a lab scale trial that they did in South Africa. I went to the conference, came back, and then the next season we tried it out on our diffuser. It worked very well. And then the fifth point is, see, now in anywhere in the world, you talk of the sulfitation in the sugar plant, the fellow gets almost a fit. But here, we very successfully did it, and our sugar that we produce is farmer grade, and less than the ppm that the FDA stipulates. The rest of the things you will see is the quality of the sugar. And the eighth one is bagasse place. We are using flue gas heat from the chimney flue. We are using that to dry our bagasse, drop it about 8 to 10% moisture. It does a lot of good for the boiler capacities. Here I just given a rough idea of what we see. If you see here is this is boiling bagasse. It's less than 1%. Whereas what you find anywhere in the cane sugar industry with the mills, more than 2. And so sugar that is produced in the field is actually burning in the boiler. And in fact, that 0.84 we brought it down to 0.5. And that's that much of extra income that you can get. And diffusers, I think we here also there's so many times much better than military, but for some reason people are reluctant to move. This is what a diffuser is. It's a big railway wagon there, and you feed the gas in here, and then it moves slowly right there. And you have on top you have distribution systems, and at the bottom we have a truck where the juice percolates, collects down from here. By the time it comes here, it's like an osmosis process extraction of juice. See how much of extra power you do versus a milling tank. Because this needs very little power to operate it. And this is actually the worksheet on the day that I actually prepared this. And this is a 12.49 is actually recovery. And giving more time here so that you can actually have a look through the board. Long enough, you want to change everything. Most of the data is what generated in our plant. So this is everything what happened in our company. Whatever you see here is what actually has been done. No assumptions here. Here they actually suggest Peter suggested it should be 94, but even with 90 we were still able to get to the inspections. This is a graph to show how uniform the whole process through the diffuser. There's a lot of doubting Thomas is saying that may be going wrong, this may be going wrong. I think it was not everything was provided you operated the way it's supposed to be operated, which is very easy. Here is the minimum immersion loss. And the extraction is all at 80 degrees C, so there's no bacterial problem. In fact, all our sugar qualifies to be palm-grade sugar. This is from Watermelon Sugar Institute. On the start side, we never get start, but I want to make that everything. Here some places I've given a little more detail on color profile and all that stuff. I don't know how many of you are interested in that, but I thought it would be interesting to know how we are able to achieve that no 13 points that show how much better a diffuser is representing things. For some reason, people don't want to change. Everything is positive. There's nothing negative there. See, we actually throw out the vacuum filter station. We don't have a vacuum filter station. And then, if you see the next one after that, they're actually doing even the juice clarification for the diffuser. So even the juice clarifier is out. There's so many advantages. The extraction is better, lower manpower, lower residual consumption. Operating cost is less than half of what you need to operate a milling. See, this is the what, like the X-ray got accidentally invented. This is an accidental thing that the son downloaded for me, and then we tried it out. We had a very, very good result. So that is because of this oxidative polymers, the phenol compound gets displayed. So once you see, phenols are the culprits for the color formation residues. Once you get rid of phenols, the rest comes to this to produce the white sugar. And I think there's a lot of thing happening is in the cane sugar. What I observed was you have to look at the water side and then the farmer side, whatever new developments could be applied there. See, this is the what we tried for the rotation, how we put it through. See, we don't use any chemicals and nothing. And here you see the color. We mentioned the color also. Here, this is the main thing. See, because of the oxidation and the phenol getting out, that's the percentage that's going out. That's the reason we have a reduction in color. And it's nothing. We're just pumping in. No other chemical.
In these mills,
Yes.
okay, how many pounds or kilos per ton cane of mud?
We don't have mud now. Mud goes into the diffuser. So
Yeah, I know. So therefore, you're stripping the cane, hand stripping the cane.
Yeah, well, it's not actually all hand. It's not the old days of hand stripping. Not anymore. It's just cutting the top and the bottom. This is again Vadim's. I picked it up from here. About the technology we used it there. One of our plants is using this. And actually I presented this in Australia at the RSC workshop. And they were quite surprised. They thought the SRI museum clarifier was this is much better than that as far as performance goes. And like Kumar said, we were able to actually do it in 24 hours. One of those DRT stuff, and we tested it out, and then the following Tuesday we tried it out. Yeah, what we did is we had an old unused reward clarifier shell. We used that, we threw all the internals out and put Vadim's stuff in. It worked, and it worked very well. And then we scaled up, we had a graver table thing that we modified to this. And we did a comparison between the label and SMA museum. Fortunately, we had a what is the magic created there. How it neutralizes the turbulence. Yeah, this is what we built at our plant. These are all the devices that reduce the turbulence. Very well, right? We never had a problem. Never had it. Very cheap to modify, very cheap to build. And this is the grain that we were able to show. We compared the graver to, I don't know whether that was right, the old man with the young guy. The graver is a very old technology, but it is being used by quite a lot of plants. This made a no difference. You get a nicer inversion losses. And you can see the difference in building a graver versus, and this is a new gen. This is cheaper by 54% compared to a new generation type from SLA. And these are all in-house. These are all from what we had. We built a graver. We modified one door into a SRI engine, and then we built one fresh. So all these figures are what we actually have in our plants. No assumptions and no hearsay. So this is how clear we can actually read Borosil through the juice. I don't know, anybody from had an option to see Sterling? They also have a similar test, but I don't know how clear their juice is. The main thing is the retention tank. And of course, even a SRI union, we did get as clear a juice. This is another thing we tried is, I went to Shasta and SMRI had done a lab scale trial. Nobody was willing to try in South Africa, so I came back home and we tried it. Next crop we tried it in our plant. And we invited some of the South African guys to have a look. It worked very well. Though not for us, for a raw sugar plant, you can blindly go. But for us, because we do direct white sugar and low color, so we have to still do some fine tuning. But for raw sugar, this works pretty well. You can throw the juice blender out. Here, what we did was we had two extra compartments for the diffusers that we built. So those two extra compartments we used for doing the clarification. I don't know whether anybody is playing these, but we tried. Not much of a difference, but still it does take some of the legacy out. from what was clarified in the diffuser, and this is from the regular juice clarified. You do find a little difference. If we have to do direct white, we need this. But for raw sugar, this can be done. Anyway, doing raw sugar, you don't need juice clarified. So they said it's suitable for low color raw sugar. It need not be thousands, it can be less than 100 color. This is another thing we tried is, in India and China we use sulfitation. But you talk about sulfitation, anybody, they get fits. But we've been able to use sulfitation and still produce sugar that is pharma grade, around 30%. And this is a very, very compact unit. I got the design done in Brazil and we built it in-house. See here is we don't use any steam at all. And the power is very low. You don't need much of it. Power is not very small, low really set the thing up. This is the rotary where we have a screw. This is a screw to feed the sulfur. And then it burns in that. So this is the ejector. So actually SO2 dissolves under pressure. So you never even get to smell any SO2 escaping. It worked very well. In fact, plant employees are very happy with this. We initially did it for juice, and then we got them to design one for syrup, which they've never done. Brazilians have used it for juice, but never for syrup. They're the only guys using syrup. And we've never had a problem. It's given us quite a good results. I've been visiting Brazil from 1980 and I saw this, asked many fellows whether they can do it for us, they never understood. So we got the Brazilians to design it for us. And this is the same thing, you see the difference between. This is a very nice light color. In fact, here, if you see clear juice, it's a bit like coffee decoction. This is another advantage. It's very clean because of being operated at first education. And it's very compact also. The next few slides we've been using for the last, this complex, we were looking at US pharmacopoeia and sulfates. It compares to US pharmacopoeia. Many people are very, very apprehensive. They say very injurious to health, that this, if you operate it right. Our experience has been that, and we got it tested by, and see even here, 639 Nikumsa. This was done by the Berlin Sugar Institute. And you'll see the next slide, the even sulfides, they're non-detectable, they're very low. See here, this is nothing. So there should not be a problem using sulfidation. And I think there is a sugar that we produce. And this is, we got a lab in India where Pepsi uses. We got them to test our sugar, and this qualifies for even PepsiCo. And bought as Pepsi Coke. But I've never let those two companies come to my gate because I get a better price than what they offer. Yes, sir. Well, that's what people ask.
It's the highest. I can see that it's 2 mg per kg SRP.
Yeah. No, you talk to any sugar processing guy, see here, we were able to, the Kumsa is only 22. And your refined sugar is 20. So why do you need a refined? All that millions of dollars you don't need. If you, and that's the quality of sugar that we produce. See, we go in for a higher grain size compared to the others. And this is medium. Actually, we use even large. Capital market is a market for large. So you've got to use that much extra steam. See here, medium grain size and small grain. I've given you all the details. I've given you next is color profile, how we achieve the 30 color. Ultimately, we come down here. See, this is what we pack. 30 Actually, I think Alkali is from Dubai. That's what they're doing to Brazil. They're getting them to give a very VVHP sugar and paying them a little extra. But that must save them in their processing in Dubai. That's why I say it could serve for producing low color sugar shouldn't be a problem. We've been doing it for the last 70 years. This is another thing we found is, see, there's a lot of heat going up in the flue gas duct. So we use that with just a drying tube and a cyclone. The rotary valve is only to the feeding area where the gas is going in. Otherwise, there's no moving part at all. Very, very simple job. Many people ask fire hazard because they use the wrong drive. They use the rotary multi-pass drives that in the corners they get stuck and then over dry and then you fire. But this stuff, you know, I don't know. See, for every 1% increase thermal efficiency for it, you save that much. And actually, you're using what you're otherwise going up in the air. And another thing we found was, but by the time you do this, it comes down to 70 degrees C, and so you have a dew point on the top. So many people say, oh, sulfuric acid, as long as you're not burning coal and it's just gas, no problem. And then what actually happens is very, very fine carbon that escapes. It picks up the moisture, gets heavy drops down. So your environmental guy doesn't have a reason to complain. It is much pure, this is where we achieve. And we increase the thermal efficiency to almost. See, this is two type of drivers. We tried this. We tried this first, and then the designer I took from Cuba. So then I said, what the other stuff we can? And then he said this. So we tried both. You'll see the next slide. You'll see the comparison. See, this is where you get the fire accidents. The rotary drives, that is the fire accident. This one, there's no way. I don't think there's no way you can actually have a fire. And this one actually, this is Australian design. They cut into the boiler thing, and there you don't need to do anything. What we are using is this flash drive. This is the drying tube and the cyclone as well. Very, very simple. But of course here I think because you have surplus by gas, you don't know what to do. You do not be of interest, but the cogen it's very interesting. These are the two different types that we used. This we tried first, I think around 2000 or something. Then after we went in for these days, there's quite a lot of sugar plants in India that went in for these days. is our plan. For the core products, we do about total of 12 products at our cane sugar operation. The next slide, you will see the chart, but this I wanted to show you that how these different units are actually located. It's nothing on the chart. It's actually right on the ground. And here you will see it's just 5 raw materials that you use, and you get 12 products. And the blues are all the byproducts. And this is the last, this electroporation. See, this is the electroporated bead and electroporated. So the next step, I think, even diffuser is going to be obsolete. If you start using electroporation, that's probably the way you go. In fact, I offered Dr. Peter Ryan to give a project for trying electroporation on cane. But I think I found the document to be more like a Shylock, so I backed out there. But if there is a better document, then you're going to be too happy to get somebody to try that out. Because it will make sugar processing that much more easy and better. Thank you. I'm not a technical guy. If any doubts you have, you just put your email and whatever questions you have, I'll have them answered. Yes, sir.
Maybe this can be like a motivation.
Yes.
How does the product value of this refined sugar changes between the dropping this color? You're trying to bring it like this with 33 ID.
Yeah.
Oh,
see,
how do you don't achieve that?
Pardon?
Yeah, this is like when we are putting the sugar in coffee and all,
Yeah.
it's not like brown sugars.
Yeah.
I'm assuming that nutritionally they're not very good. Are they? Or
Refined and brown?
yeah.
I would prefer a brown sugar. It has more nutrition there. Here. Actually, white is only good to look at, not nutrition-wise.
Okay. So
Lot of minerals you are actually washing it out. Brown sugar has all those, whereas the white one it doesn't have all those. All those are gone. Not gone into the molasses.
So why is white product higher than that?
That's what looks better.
That's it?
I don't see any other reason why they have to pay. I would not, if I had an option, I'd buy the brown sugar, not the white sugar.
So this entire plant, this way, all these processes are done just for making it look good?
Yes.
You have to remember, in a refinery, 90% of your product is white sugar. It makes 10% of your profit. Your brown sugars, your sugar where they put molasses back on refines, etc., is 10% of your products, but they make 90% of your profit. So therefore, the whole industry is based on the fact of a colonial empire, where the raw sugar is made overseas, and then brought back to England or Portugal or the Netherlands and whatever. You refine it there and therefore make the profit there. It has nothing whatsoever to do with the product itself. The antioxidants, etc., are much higher in a raw sugar. The raw sugar tastes a hell of a lot better.
Yeah, definitely. It has everything there which you're throwing out in the white.
But you can't make money from a raw sugar when you have a colonial empire.
Yeah, right.
On the gas line, are you running scrubbers afterwards or you don't run
You
scrubbers?
don't need a scrubber. Why do you use that? Bagasse there itself is a scrubber.
Okay.
Because bagasse is dropping down.
Yeah.
And it's actually trapping the carbon, taking it back to the boiler. And because of the dew point in the end of the chimney, whatever fine is there, it absorbs that moisture and falls down. It doesn't go out. So bagasse there does the job. You don't need a scrubber.
And when you did the clarification and the diffusing,
Yeah.
did you try without sulfitation?
No. we tried it with the sulfitation.
With the sulfitation, do you think it would work even without sulfitation?
We never tried it, so I can't say. But definitely with the sulfitation, it did well. For raw sugar, there's no problem. You saw the difference, right? There's still a little darker color. We need a little more homework before we can use it for direct ones. Yes, sir.
I was pretty impressed with the last part of your presentation. You made 55% more power using this kind of refined sugar.
Now, see what happened was when we set up the plant, we had a back pressure turbine. We never had a condensing.
Now, pushing into this like another half, which are one of the lesser solar.
Yeah.
This would be completely, self-sustained powered unit without.
No, even now, sugar plants, every sugar plant is self-sustained.
They don't need to be on the.
No.
They actually export some bagasse.
That is only wheat sugar furnace. They have to buy from out. But now, if you start using bagasse for something else, then cane sugar furnace also has to buy power from out. But here, what happened was us. We had the bagasse there, we had everything there. So, what we did was off crop, what we saw there as off crop. We used one of the evaporator bodies as a condenser and still produced power. But that's not the most efficient way of doing it. But if you had your extraction condensing turbine, then you would have got that. So the same bagasse that you had, you would have had another more explosive inside. But that would cost you that much more to buy that turbine. And I'm not a guy fan of cogen or ethanol because once the lignocellulosic use goes up, you will get more money producing that rather than burning it in the boiler. So we've gone this other way where we spent 20 lakhs and we're exporting what, about 10 megawatt. That also for our own plant. We have a caustic soda plant which we wheel and that's it.
Okay, I think let me conclude by saying that I understood after this speech what X can mean, what is the thing that drives this innovation. Obviously, you travel phenomenally to 30, 40 countries or so, wherever sugar is produced, and observe the best practices in each place, and then say, okay, I'm going to try that, I'm going to try that. And by drawing the best practices from everywhere, you seem to have the best plant in the world. We need that kind of synthesis of, maybe you should somehow publicize.
That's what I'm really encouraged.
Well, this is that.
See, I did the same presentation. I did 2 places on that. Both for PSP and Lower. Then I did it at Mauritius, Sugar Institute.
Okay. So you're not only absorbing, feeding back to the, So it's really wonderful. Thank you very much for this presentation. Please join